I'm Mona Vajolahi. I'm a product manager at Google. I work on making the web fast, and more specifically, I work on page speed products.
My name is Doantam Phan. I'm also a product manager working on Make the Web Fast.
And I'm Bryan McQuade. I'm the technical lead of PageSpeed Insights.
All right, so I want to start by showing you a video that would capture the impact of the recommendations that we are going to talk to you about today. So here's a sample Wikipedia page. We are going to load it on a mobile device, a 3G network. And on the left-hand side, you'll see the Wikipedia page, the original version. The right-hand side, the optimized version, is after we implemented the best practices that we are going to share with you. So let me play the video. So as you can see, the original one takes some time to show something on the page. And overall, the original finishes in 5 seconds, whereas the optimized version finishes in 2 seconds. Now, let's have a closer look at what's happening here. So even more interesting is that the optimized version actually shows something on the page around the 1 second bar, whereas the original version, in the original version, we are staring at a blank screen for almost 3 seconds. And here's what we are going to do today. We are going to try to get some content on the page around that 1 second bar. Let's see, just a quick agenda of the talk. So we talk about why speed matters, and then we're going to share the recommendations for creating an instant mobile performance. And also, and in the end, Bryan is going to do a deep dive in one example and show you in action how we can do that. So we all know that mobile connection speed on mobile, 3G or 4G, is slower than your average connection speed on desktop. However, users on a mobile device actually expect the sites to load as fast or even faster as what they have on the desktop. So there's a problem. More than that, users of mobile sites actually learn to avoid slow sites. And that first interaction that they have with the site, the first experience they have, is actually really, really important. In an experiment of adding additional, one second additional latency to a shopping site, it actually saw that page views will decrease if you have additional latency, conversion rates are going to drop, and bounce rates are going to go up. More importantly, what happens is that that bad experience sticks with the user. So they are less likely to come back to the site and less likely to go back to the site. So here's what we want to do today. We want to make that first experience really fast and snappy so that we actually get the users to come back and visit the site more often. So the topic of today's talk, we are going to show how we can get the most important content of the site to the user under 1 second. So that most important content usually is what you see above the fold of the page. And why we pick 1 second? Because user studies shows that that is the limit that people are going to pay attention to your site. So after that 1 second of staring at a blank screen, users are more likely to just step away and basically never come back to your site. And today, the average page load time on mobile is 7 seconds, which is a huge gap from where we want to be comparing to where we are today. Now, we all know, 4G bandwidth is much higher than 3G, so that should solve our problem. And basically, experience on mobile would be very fast on 4G. Well, not quite. Let's look at the difference between bandwidth and latency. Bandwidth is the amount of data transferred over the network per unit of time. So for example, a network can have 5 megabits per second of bandwidth. However, latency is the delay in transferring a packet from a source to a destination. So for specifying latency, we usually use round-trip times. Now, if I have huge amount of data that I want to transfer on a network, like if I'm loading a video, obviously bandwidth matters a lot. But when I'm loading a page, there's a lot of small requests going back and forth. And in that case, bandwidth is not helping me a lot. So what happens is that latency in loading a page is dominated by round-trip times. And now round-trip times on mobile networks are especially high. And on an average 3G network, for example, you have a round trip between 100 milliseconds to 450 milliseconds. On a 4G network, you have between 60 milliseconds and 180. And as you can see, the difference between 3G and 4G is not huge here. So in order to get that snappy user experience, we have to design for this high latency environment. And we have to try to reduce the number of round trips as much as possible. And that brings us to the rules that we are going to share with you today. These are about how to create a fast user experience in a high latency environment. It could be when I'm using my mobile phone to load a page. It could be when I'm using my laptop and connecting to a 3G network to load a page. So the 4 rules are: 1, avoid landing page redirects; 2, minimize server response time; 3, eliminate render blocking resources; and 4, prioritize visible content. Now, what we are going to do is that we are going through each one of these rules and tell you why we picked those and why they're useful. So let's just start by let's see what happens when a user visits a site. So I go to my mobile device, mobile browser. I enter www.example.com in the browser. What happens is that there's going to be a DNS lookup to fetch the IP. Then there's going to be a TCP connection established. Then the request is sent to the server. Server takes the request, processes the response, generates the response, and sends it back to the user. So we already have 3 round trips plus server processing time. Now, if I say on an average network, the round trip time is 200 milliseconds, that brings us to 600 milliseconds plus processing server response time. Now, let's say www.example.com actually has a redirect to m.example.com. What happens then? In that case, there is another DNS lookup, another TCP connection, another server send and response, which basically doubles our latency. So there is 3 additional round trips. If we are over SSL, it's actually 4, and brings us to 1.2 second total latency. And this is all before any of your HTML content gets to the browser. Now, if you look at this, there are parts of this that I, as a developer, have no control over, right? I cannot do anything about DNS lookup, TCP connection, send and receive. But what I do have control over is the redirect and server response time. And that brings us to the first rule, the first 2 rules, that says avoid any landing page redirect and minimize server processing time as much as possible to reduce that latency and to minimize the RTT time. Now, Doantam is going to tell you more about the next 2 rules and why they are really important.
Thanks, Mona. So we've seen that there are various things that you can do to your network by adding extra redirects, by having a high server response time that really slow down the user perceived latency of your site. What I'm going to talk about now is actually the way that the structure of your page, the HTML that you use and how you organize it, can actually also lead to a huge increase in user perceived latency. And the way that we're going to do this is we're going to look a little bit into the browser rendering pipeline. So what I have here is a simplified diagram. And you can see that to paint anything to the screen, we both need the document object model to be ready and the CSS object model to be ready. And it turns out that both of these things are going to depend heavily on having the presence of external scripts and style sheets. To see how this actually affects user perceived latency, we'll go through this brief example. So here I have a very simple HTML web page. I've grayed out all the text because I want to indicate that the parser hasn't actually gotten to the HTML yet. On the right-hand side, I have a representation of what the user sees, a smartphone. And at the bottom of the page, I have some representation of the internal state of the browser, right? So I have the pipeline, and I also have the various external files that the HTML references. So from our perspective, the first interesting event is when we discover example.css. So at that point, you can see the progress bars on the bottom are indicating that I've started parsing the HTML, I've started constructing the DOM, and I've initiated a fetch for the CSS. The next interesting event, and from the perspective of user latency, is when I encounter this div that presents some text to the user. Now, ideally, at this point in our rendering pipeline, we'd want to show this text to the user immediately, right? Because the user has clicked on our site, and they're waiting, staring at a blank page and a progress bar. But due to the way that this div depends on the styling information inside external.css, that's going to cause the browser to not know what to do. And so it's just going to continue parsing the file. And so this is where you can see that the latency is going to creep in. So similarly, as I encounter the image, as I encounter the JavaScript file, I'm also going to have to initiate fetches for them, but I still can't show anything because the CSS file hasn't yet loaded. And so it's only finally when the CSS file is loaded off the network in memory that I can actually pop something up on the screen to the user. At that point, the user is finally engaged. Up to that point, they're just staring at a blank screen. And so an important thing to note here is that the DOM can be constructed iteratively as you're parsing through the file, but the CSS object model is only constructed once all the CSS is in place. And this is really the reason why a lot of web pages feel slow on a mobile device, or really on any device. It's just not as noticeable on a desktop due to the way that latency works. Oh, and so as we continue parsing through the file, we're going to finish loading the JavaScript. We're going to finish loading the image, and at that point, the page is ready and sort of consumed by the user, right? But at that point, they've been waiting quite some time to kind of get this information. So to summarize, the issue is that these external scripts and style sheets are going to block the painting of content in the body, right? And we're not saying that external resources are bad. In fact, it's generally a very reasonable practice on desktop to have these resources for cacheability and for easy composition of HTML. But on a mobile device, if you assume 200 millisecond latency, maybe 300 millisecond, these extra round trips to fetch every additional resource is going to be very costly. And so what you really want to do is be able to avoid these blocking external scripts and style sheets. So generally speaking, when you do this, the way that you can get around this is you can be smart about the CSS, right? You can inline parts of the CSS that are responsible for the above-the-fold content in the header of your HTML file. And so then when the browser is parsing through the file, at the point that it encounters that div, it knows how to style it and paint it to the screen. And that's really where this third rule comes from, this notion of eliminating render blocking resources. Understanding that there are certain things in the rendering pipeline that will block because they don't have the right information, and making that information available to the browser at the right moment. So let's say that I attended this talk and I saw these three rules and I think to myself, hey, I'm done. I can just inline everything and everything will be great. And I just want to add an additional caveat, which is where this fourth rule comes into play, which is this notion of the additional latency that comes due to the slow start of TCP. So in this example, I've actually inlined all the CSS that I have. I've put all the styling information there. In fact, I've gone the extra step where I've added in the icons as data image URLs in the header of the CSS. Now, the problem is going to come up that, keep in mind that we want to reduce these round trips, right? And so if the initial above-the-fold content of your page is over 14K, over that initial TCP congestion window, that's actually going to incur an additional round trip. And so you need to be really careful about how you inline something. You can't just blindly inline a file, unless, of course, the file is below that cutoff. But if the file is above that cutoff, you're going to need to figure out what are the critical parts of CSS and what are the non-critical parts of CSS. And then you should use delay loading and asynchronous stuff for the parts that are not necessary for that initial user experience to really get to something in 1 second. So, and I want to emphasize that we're not saying that you should only make your whole page fit in 14 kilobytes or 15 kilobytes, because that is kind of really stringent and actually fairly difficult to do. You only need to make sure that the above-the-fold portion of your page fits. And actually keep in mind that with compression, that's actually going to cause us to get a lot more space, maybe up to 45K of text. And so that's where this final rule comes from, this notion of prioritizing the visible content. Right? So be smart about what you're inlining and make sure that it fits within this congestion window so that the user can get that content right away. So now Bryan is going to go into an example about how you apply these rules to a real site.
Okay. Thanks, Doantam. So I'm Bryan McQuade. I'm the tech lead of PageSpeed Insights. And I'm going to take what we just learned from Mona and Doantam and apply that to an actual sort of website that we created to work through and see how much faster we can make that website load on mobile. So we have this demo website, demo.modspeedy.com, that we put together. It's a simple page, simple mobile page. It sort of has characteristics of standard mobile websites. It redirects to an m.dot site. It has a little bit of server processing time. It's reasonably small, and it has just one style sheet in the head with some data URIs. The page looks like this on the right. And it's a simple page, right? We would expect a page like this to load quickly. We would hope anyway, right? It turns out, and I suppose I should clarify, this doesn't have, so modspeedy.com was a domain we had available to sort of create a demo. It has nothing to do with Speedy, it's just happens to be on that domain. So it turns out, so now we'll sort of dive in and we'll look at this page, figure out where the performance bottlenecks are, apply these optimizations one at a time, and then observe the improvement in load time that we get as a result of applying those. So to start, we have this unoptimized page here, which literally just has 3 resources. We've got demo.modspeedy.com, which redirects to m.modspeedy.com, which then loads a single static CSS resource. And what we see is that, unfortunately, the load of these resources is completely serialized. And we essentially incur, because it's on HTTPS as well, we've got a 4th round trip in there. And the end result is that we're looking at about 6.6 seconds of latency before we see anything on the screen, even for a simple page like this. So let's go ahead and look a little further. So to start, right, we've got this redirect, demo.modspeedy.com, which redirects to m.modspeedy.com. And we know that's costly. Mona has showed us. In fact, in this particular environment, we're using web page tests 3G modeling. Round trips are actually 300 milliseconds. So we've talked about 200 being a good sort of general target to sort of be in between 3G and 4G, but for 200 milliseconds, that is. For this particular demo, we're using a 300 millisecond round trip time. And on top of that, because it's on HTTPS, we're looking at 4 round trips. So that redirect ends up costing us by itself 4 times 300, 1.2 seconds. So the question becomes, well, how do we avoid that? How do we avoid that cost? There are really 2 good ways to approach this. At a high level, we have to make sure that we serve the user content at the URL they request initially, right? It's just, if we redirect them from demo.modspeedy.com to m.modspeedy.com, we saw we're inherently going to experience that additional latency. So what we have to do is instead serve the right content to the right users at the URL they request. So what that means is one of 2 things. Either use responsive design, which allows you to serve the same HTML to all your users, be it mobile users, desktop users, and the page will render sort of differently depending on the device characteristics. Or, and so that's, I should say, that's a great approach if you're sort of building a site from scratch. I think that's the right way to go. But if you've got an existing sort of mobile website and desktop website, and you're just trying to figure out, well, how do I move from having this redirect to not? Then what you want to do is make sure that you vary the content, the HTML content, that you serve to your users based on the user agent coming in at the web server. And so if you're getting a request from a mobile user agent, you serve the mobile HTML directly. And if you get a request from a desktop user agent, you serve the desktop HTML to them as well. So let's go ahead and actually look at, so it's easy enough to sort of say just go ahead and do that. Let's go ahead and do a quick sort of example. I'm actually on the web server for modspeedy.com now. And we can take a look. In demo.modspeedy, in the demo directory, we've got a couple files. This is an Apache web server. So I'm going to go ahead and actually bring up the htaccess file for demo.modspeedy.com. And we'll see that htaccess file is an Apache file that lets you specify sort of additional information about how content should be served. And what we've done here is we have this rewrite rule that basically says, conditionally apply the following rule if the HTTP user agent matches either iPhone or Android. So basically a very simple mobile user agent matcher, right? You could expand on this. And then if that matched, go ahead and rewrite the empty URL. So that is, the URL with just a slash, essentially no URL, just the host name, to HTTPS m.modspeedy. Right? So that's the costly one that we just looked at that incurred that 1.2 seconds of latency. So if instead we tell Apache to rewrite that URL to a file, right, a local file, then what we'll get, so let me do this actually. Let me go ahead and put demo.modspeedy.com in there, and we can see it redirects. Right, so that was before. And if we just switch those, so now I'll go ahead and do that again. Then now we can see that the content that we had been redirecting users to on m.dot is now served directly from demo.modspeedy.com. And just to sort of close that, so it's a pretty simple thing to configure, right? This is the Apache variant, but if you use a different web server, they all sort of support this in different ways. And then just to look, so we're saying basically serve up mobile.php instead, right? Why don't we look at what that file looks like? So, oops. That's just a symlink over to the m.modspeedy.com index file, right? Which is exactly what we were redirecting the user to before. And so now we're able to avoid that redirect. And let's see the effect of doing that on the page load time. So if we sort of think about what we expect to happen here, we're removing, as we talked about, 4 round trips, DNS, TCP, SSL, and request and response, each of which cost 300 millis from the time to display. We were at 6.6 seconds before, and as a result of removing that redirect, indeed, we see the load time of the page drop to 5.4 seconds, which is exactly what we expect, right? So we've sort of confirmed through our test environment here the result that we would expect to see. And by the way, did I mention, so this, I don't know how many people are familiar with web page test? Okay, so not most. So I would definitely, so we've used web page test to both produce these videos and the waterfall underneath, which shows sort of the resources that are loaded and the time that each one is loaded at. It's a really great resource, webpagetest.org. You can tell it, show me what my page looks like over a 3G connection from various locations around the world, using different kinds of devices, get these videos, look at still frames. It's a really rich tool to understand what the experience your users are seeing is. And so we've used that to create these here. OK, so let's go ahead and dive into the next. So we've improved the page, right? We've gone from 6.6 seconds to 5.4 seconds. But it's still by no means fast. So let's go ahead and dive in and talk about server processing time. So here we've got a page that's got, well, let's first sort of take a step back. So there's sort of 2 things you want to think about when you're thinking about server processing time. One is, what is your server processing time? How do you measure that? And 2, if it's high, why is it high? And what can you do to sort of reduce that? And so we can go ahead and take a look at that actual page we have. I'll bring up Chrome DevTools. Bring up the network tab. And then I'm going to go ahead and reload. And so we can see here that the waiting time, when we click on the resource for demo.modspeedy.com and the timing, the waiting time, I don't know if you can read that, it's pretty small, but is 1.6 seconds, right? So we've got 1.6 seconds of time between the time we sent the request and the time the first bytes of the response came back. So that's quite high. We'd expect to see maybe 1 network round trip there, but 1.6 seconds is way above that, right? And so then the question becomes, well, why? What's going on there? Why is it so high? And so it's a little bit outside the scope of the talk to sort of figure out and understand server processing time deeply. But at a high level, what you need to do is essentially measure this server side. So what are those times? And then ideally have some monitoring infrastructure in place that helps you understand, if it's high, where that time is going. And so one of the tools we like for this is called New Relic. They have a free offering that you can use. And it lets you see at a high level sort of where time is going within your application. So I'll go ahead and just bring up the New Relic view for this web page. And so this graph in the middle here is showing us over time sort of how long the server took to generate the various responses that were requested for the particular URL we're looking at. And so we've got a breakdown by database time and PHP time. And so we can see that by and large, recently anyway, and so I should say these sort of pits are just places where there were no requests. It's a demo page, so there's not a whole lot of activity here. But by and large, we're seeing pretty substantial time spent in the database querying, and a little bit of time in that blue, though non-zero time, right? A couple hundred millis in the PHP sort of execution environment. And so then the question becomes, well, why? What are we doing? And what can we do to sort of address those? So I'll just look really quickly, right, at our page. And this is, just a simple demo, right? But sure enough, we've got sort of 2 things where, get data from database and then render the HTML with that data, right? And we're ending up, I've sort of created the queries in such a way that they're intentionally slow for the purpose of this demo. But this is something we see pretty often, is that pages will have, multiple second first byte times as a result of spending a lot of time either in the database or executing PHP or possibly some other reason. But in any case, so now that we know that, the question becomes, what should we do? So why don't we go ahead and switch back? So what can we do to sort of reduce this time? And our options are really, remove, defer, or optimize. And in this case, I observe the page we saw. Yeah, we can bounce back to that. Right, the page is generated dynamically, but it's really static content, right? And this is a common pattern you see too, right? You've got a page that's mostly static, or it might change periodically, but fundamentally it doesn't change on every request, but it's still generated dynamically from the database on every request, and that ends up, in some cases, adding a good bit of latency. So in this case, because it's mostly static, we can simply just, whenever we update the database to have a new product or whatever it may be, just render that to HTML, right? Dump that to a static HTML file on the web server, and then just serve that instead. And so I've done that. Or I thought I did that. I did do that. It's over here. And we can see now, we'll go ahead and reload it and take a look, that our waiting time has gone from that 1.6 seconds down to 84 milliseconds because we're not invoking the database and running the PHP engine on every request now, right? We just rendered this to static content, and we're serving that instead. And so in general, as much as you can pre-compute, ideally all of the content, if your pages doesn't have any dynamic pieces. Many pages do have a little bit that's dynamic, but if you can pre-compute the majority of it to minimize the work in the request path of the user, you'll create a better experience for your users. So that, yeah, let's go ahead and switch back. So that's server processing time. And so now we can see, that was about 1.5, 1.6 seconds we saw. And indeed, again, we were at, 5.4 seconds, and now we're down to 3.8 seconds. So we've reduced render time again by another 1.6 seconds. And you can see that if we go backwards a little bit, nope, not like that. Right, this sort of green region right here in the old version was quite long. That was that server processing time. And we can see now that that green region is much shorter. And that's where we've pulled in time, and that's resulted in a faster render on the screen. So let's keep going. We're doing well, but we're not to our 1 second target yet. And I guess a spoiler alert, it's physically impossible to get to 1 second in this configuration. So we're not going to get there, but we're going to get as close as we can get. We're going to get quite close. So let's see how close we can get. So as Doantam talked about, the load of our external CSS resource blocks rendering of page content. Right? So that actually ends up incurring 7 round trips right, on the network. And at 300 milliseconds, that's a very substantial cost. So the first thing we can do, very simple, very easy thing, is just simply experiment with inlining all that content. And people do this a lot on mobile. This is a pretty common technique, right? Just inline, inline, inline. As Doantam talked about, there are some drawbacks to that. So we'll start with that. We'll start with inlining. And then we'll sort of iterate from there. So if this is our first page, right, with the external style sheet, then we can simply, as Doantam showed, inline all the styles and serve it up. And so what does this actually do in terms of load time performance? And so what we see is we're down from, I believe it was 3.6 seconds before, and now down to 2.4 seconds. So we've removed 1.2 seconds, which interestingly is the 4 round trips from the DNS, TCP, SSL, and request response of that external style sheet. We've essentially eliminated those. We still have the round trips for fetching the style sheet, though, right? They've just moved to be inline. And we're still paying that cost. And worse than that, we've moved those assets from a cacheable resource, right, a CSS file, into sort of a non-cacheable HTML payload. So repeat visitors to our site are going to end up downloading that content on every visit, which is pretty undesirable, right? And so let's see, as a final sort of optimization, if we can go ahead and address that issue and make the page faster. So the only issue we're faced with now is that we've got this large blob of CSS in the head. And as Doantam talked about, that ends up delaying render of the page due to the TCP congestion window growth. And so what we want to do is essentially identify the critical CSS, right, that CSS that's needed to style and position content on the page, and load that inline in the head. And ideally, that's small. And then defer the sort of non-critical CSS. So let's see what that might look like. Right. So if we sort of take note of the fact that the CSS is largely data URIs, right? And those data URIs are big. They also don't compress very well. So they end up taking a lot of network, a lot of time on the network. If we sort of say, well, we'll reserve the space for those images in the HTML, right? We'll carve out that 100 by 100 pixel block. And we'll make sure to put that style in early so things don't move around when the style sheet loads. But then we'll load the remaining content in a deferred style sheet in a way that doesn't block render. Then we can make the page faster and recover a lot of the caching benefits of externalizing that content in a CSS resource. So let's go ahead and take a look at the effect of that. And so here we've achieved an even more dramatic speed up of the first paint time. Now we're at 1.5 seconds to display almost all the content. You can see that the Chrome icon comes in a bit later. And so it's interesting to look at the waterfall. For the first time, we've actually moved the paint line from the end in, and we can see the first paint line here, this green line, actually happens essentially before the deferred style sheet has to load, right? So we've basically achieved a render very shortly after the 4 round trips we incur for the network cost, which is about as good as we can do on this page. And then the remaining deferred styles come in later, and they automatically kind of, we'll watch it again just to see it, right? The Chrome icon comes in at a slightly later time at the end. And so one other thing I did, just as a kind of advanced optimization, if some of the icons on your page are really high priority, you can inline low resolution previews of those, and that's what I've done with the page speed icon. And that causes that content to show up a little sooner so the user can see it, but doesn't have the cost of downloading the full image asset inline in a blocking manner. So just real quickly to close, let's go ahead and look at where we were and where we ended up. So we went from a first paint time of 6.6 seconds to about 1.5 seconds, which is just about as low as we can get, right? The sort of absolute minimum is the 4 round trip times of 1.2. So we've got a little bit of browser processing time in there, and we've basically streamlined this as much as is possible. So that's it. So at a high level, right, designing for high latency means following these 4 best practices: avoiding landing page redirect, minimizing server processing time, eliminating render blocking round trips, and prioritizing visible content. Any questions?
So, thank you. Several of the tricks that you proposed here would cause the same URL to serve both mobile and non-mobile content. I think that's still considered a no-no by search engines. Is that?
No, I'm not a search expert, but there's a good bit of content on the webmaster site for Google specifically that talks about the different ways you can sort of address this issue. One of them is to have separate URLs, but we actually show how you can support both responsive design and varying the HTML. So both those techniques are supported at least by Google, and really should be by all search engines. If they're not, then because that's, yeah. Does that?
Yeah, I mean, in this specific example, the site was very clearly mobile. Like, I wouldn't want to see that on a browser.
Oh, I see. So what I didn't actually do there was a line in my htaccess that actually allowed it to conditionally execute that sort of redirect to the mobile thing, depending on the user agent. So we would still send. I can actually really quickly just write. So if I actually enable this, I didn't because it made it sort of hard to actually use the demo on a desktop. But now if I re-enable that rewrite cond, if you now go to demo.modspeedy.com, well,
yeah.
I don't have an index.html.
Yeah, it's because it's a backend redirect, though. If you go to that same URL on a mobile site, you might get something different. So that's why I assume that this was not intended to change the recommendation from Google. This was just like a example.
So at a high level you should, and I apologize for this, I'm not actually sure what's going on. I can debug it in a moment. At a high level, it's totally fine to vary the HTML you send as a function of user agent. You should actually, we say you should include the vary user agent header in the response as well to give us a heads up that it does vary as a function of user agent.
Thanks.
Yep.
I have a question. It's kind of a throwback. Have you played around with using progressive images?
I think that's another talk in itself. Yeah. So we're looking at that now, and we're thinking about what is optimal there. But it's definitely it's a big challenge, I think, to do optimally and efficiently. I'd be happy to. Maybe we could chat afterwards.
Okay.
Hi. I'm a user of PageSpeed services, and I find it's very cool. And I have a question about how to reduce the latency about sub request. Since we know that in order for PageSpeed service to optimize the page, it will fetch the page first and make several sub requests. And then we find, could you share a bit about how your consideration about deploy processing centers for PageSpeed services in order to make a great global product?
So I think there's Ilya, another person on our team, will be giving a talk about PageSpeed products later today, and that might be a better question to ask to him. Okay. Or we could maybe chat afterwards.
Okay, thank you.
Mm-hmm. Any other questions? Okay. Thank you.
Sorry.
Oh, we'll do one more. Yep.
Okay, so I know you used some JavaScript magic there to make the CSS load in a deferred manner. Is there any techniques that are maybe coming to just tell the browser in the style tag to say, defer this later? I don't need to do that.
I wish that existed, and that's something that I think is talked about a little bit. I think it's sort of needed. Anytime you have to use a little JavaScript snippet, it's sort of feels a little wrong, right?
Well, it's really verbose, and you can't really know what's going on unless you,
Right. Yeah, no, so I think that's where we want to be. There's no mechanism to express, basically, I want to load the style sheet, but don't have it block the render today, and so you kind of have to do it in that mechanism currently. But I think that's where we should be moving.
Thank you.
Yep.
So I had a question about putting an upstream cache in front of these web servers. And your recommendation is to vary on the user agent, which means the cache is basically made ineffective.
So that's a good question, actually. I don't know if there was a video from the webmaster team recently about this. Why don't we, so we talked to some of the big CDNs, someone at Akamai, for instance, and they actually walked us through sort of basically how you would enable this use case using their system specifically. I can point you at that if that would be helpful. Basically, it is a solvable problem that requires a little bit of additional configuration on the CDN side. Okay, guess we're done. Thank you.